Hello, everyone. Hi, hi, hi to everyone that's here. Hi to my team and my wife and the guys. Hello. So, hey guys, my name is Mário Martins. I am working in the Just Eat takeaway company, and today I'm here to talk to you guys about how to a set of tools to build a feature that's updated in real time by the server. Okay? But just so we are on the same page, let's first check a couple of examples in which this feature could be useful. The first one is like an app for the stock market. So you can just open the app and it will be updated and you don't need to actually refresh for it. And the second one is you placed an order on a food delivery app and you just be checking the app. It will update your the confirmation of your order, the delivery status, if it's ready for pickup, and this kind of stuff. Actually, this sample here is the one that led me to this study, because at the time I was developing for the takeaway application, and this whole study, this whole architecture and stuff worked pretty well. Then we ported it to the Just Eat application as well. So we also implemented the package tracking with it, which is actually when you can see the location of the driver live, until it gets to your home with your food. So yeah, that's pretty much what we will use this feature for. And in order to build it, what I wanted was to think like if I was doing a code interview, the system designs step in the code interview. So I first divided it into 3 main questions. The first one was, let's understand what's the client-server communication system that we will use first. Of course, that was not a decision that was made by me. It was something that came to me. But as it's something that impacts the system a lot, it's something that's important to study and understand. Then, given that we already know the client-server communication, let's just check how it's going to be the structure, the architectural structure of our system. And the third and last one, okay, we know the structure, we know the communication system, and now how are you going to get this information that's getting in your client and move it to show in the user interface, which is the data streaming inside of our system. All right, let's start by the client-server communication system. In order to do it, we have different options, and it's good to analyze some of them. Let's start by the simpler one. We are in the HTTP protocol, and we want to get something that keeps updating. So let's try the short pulling. For using that, we would actually make a request, and if the server has something, it will answer, and in case it doesn't have, it will just answer an empty body. All right, it would work in a certain way, but generally it's a waste of resources because we would be doing that over and over again inside a loop. So that's not the best option we have. We could improve that by doing something called long pooling, which is still the HTTP protocol, which is still a GET request that we are using to do. So the long pooling would work like this. Just think of a GET request, but with a really big timeout. You do the request, and the server will just hold this connection open until it has something to answer. Once it has something, it will deliver the answer that you need. You update what you need and request again, and keep doing that. It works well, yeah, but we are still needing to do a lot of different requests in order to update our system. So we can improve that. And we can go a little bit further and move to the WebSocket protocol, which is not HTTP anymore. It kind of uses it for the handshaking step, but it's not the same protocol anymore. So now what we have is not a request, it's an open connection. You are opening a connection to the server, and this connection is known as the full duplex connection. It's a bidirectional connection. Now, the server will be able to send message to you, to the client, and the client will be able to send message to the server. It works better. We have a single connection, and the server will be updating us all the time. That's nice, that works, But the problem here is that we are introducing unnecessary complexity to our system. We are moving to a protocol that we are not that used to work with. It's not HTTP anymore. And we are now having the capability to send something to the server, what we don't need, because it's not a chat or online gaming. It's just a feature that needs to be updated. So we can give a step back, but just keep in mind that we can open a connection and move to the SSE, which is server-sent events. Actually, it is the HTTP protocol, and it opens in a really easy way, like with a GET request. Let's just say that the client will make a request, a GET request, but in the header, it will show the intention to open an event stream. So the server will be able to, instead of just answer, it will be able to send multiple events. As soon as it has some information to send, it will send. The client will get it, be updated. So it looks like something that we need for this context, this feature. And until one of the sides wants to close the connection, and then it's closed. So we can say, at least between these options, that SSE would be updating us. It's like something that we are used to work with, which is HTTP, and would do the job for us. So it's a great option for a system that needs to be updated in real time. So let's move on and try to build an architecture to work like on the client side. And in order to do so, first let's identify what are the needs of our system, and then we'll try to like structure those needs and create something, I guess, something beautiful. So, all right, the first thing is, we just talked about a client-server connection, so obviously we need a client layer. Why a layer? Because it's good to keep the single responsibility principle. So let's just say that we have something that's responsible to hold the client. So this layer will be responsible for opening the connection and getting the events. That's it. That's enough for something. All right, so now that we have the events that we got, we need to handle those events. And in order to do so, we will create another layer, which has the responsibility to do the business and to make it available to the rest of the app with something that the app understands. So you have a business layer, which will get the events from the data layer, the client layer, and process it. And the last thing that we need is to show it to the user. We have the process data that's like provided to us in real time, and now we need to show it to the user. So we need a UI layer as well. All right, if we want to go a little bit deeper, we have been seeing and hearing a lot about Kotlin multi-platform and everything. We could say that actually some of our layers could be multi-platform here, which are like, at least in your use case, Just Eat and stuff, we have different usabilities for different like platforms. So we would like to keep the UI layer as platform specific. But the business layer and the client layer could be pure Kotlin. So as we decided it, we have to just use libraries that like are in accord to that. And we can go with that. And now we are really next to something everyone, I believe, knows, which is the clean architecture. Now we have a layer responsible for the client side. We have a business layer responsible for like the logic. And we have the presentation layer. Everything has different levels of access and single responsibilities. And that's how it would look like in your system. Here we have 3 different layers, the presentation and the data layer, which has access to the domain layer. And the domain layer does not actually need to access anyone other than the dependency injection tree. Because everything inside the domain layer will just access the repository. And the repository, as the domain layer has the interface, it can be gotten by the dependency injection tree. So that's fine. Here you can see that I introduced some design patterns as well, the data source, repository, use case, and for the presentation layer, as recommended, using the MVVM architecture. All right, so we have an architecture, we have a client-server communication system. Now we need to find a way to actually move the events that we are getting in the API client until it reaches the interface of the user. So it will get here and has to move until it gets to the view. And in order to do that, we have different options as well. Just to shorten the talk, as we just have 20 minutes, let's already cut some of those guys. So let's cut callbacks. Yes, it's an option. We could do that. We could actually create a callback system that sends from the view throughout all the layers until it gets to the client, and we have like a list of callbacks, and it's handled and sends a response. Yeah, it works. But the problem here is that generally for like more complex systems, callbacks do not scale well because it leads to something that's known as the callback hell. You like end up without knowing where the callback's coming from or something like that. Kind of get lost with your callbacks. And for RX as well, I don't want to be misunderstood. It's a great tool. It's a great reactive tool. But we are trying to do something that's pure Kotlin here. So it's good to choose for libraries that like can communicate well with coroutines and are written in Kotlin, what's not the case for RX. And also, as we have as an option Kotlin Flow, it already is a reactive tool as well, and it covers all the major functionalities from RX. So let's just skip to the options to the top that are the ones that we are used to, live data and flow. And the first option, like we have like a simple question, is that like, okay, would live data do the job to get the information in the client side and like be posted with this information and move it until you get to the interface? Yes, it would. You just request an instance of live data, it would be returned, and everything would work. In the way, if you need to process the data, you can do mappers, a transformation mapper. Everyone is used to it. But there are some minor problems here, and the main one is that it's not a Kotlin library. It's an Android library. What it means is that it is a lifecycle aware component. It's meant to be working with the Android components. So if you want to do something inside layers that are meant to be multi-platform, it might not be the best option. You can use it actually inside a pure Kotlin model. You can like find a way to import the library and everything, but it's not the best option given we have Flow. It's also written in Java, and there's this little guy here that means that it emits repeated values, which is not something terrible. We can create an implementation of live data, like the distinct live data or something like that. But it would be good to have this functionality by default. So you can move to Flow. And all right, the first point, it's not an Android library, so we are good to go. Let's keep going. It can emit multiple values, nice as well. Exceptions are handled by default. If you have like a flow stream, and you have like some shit happen there, the collector side will like be able to handle this by using like the catch lambda function. That's great, but there are some downsides as well with the simple flow as well, at least. The simple flow implements something known as the code flow property. And what it means is that when you add a new collector to a simple flow, every time you do it, you are creating a new instance for the flow. So in your system, let's just take an abstract view like of the system. It's real time, and it's being updated. We want to represent a downstream system. So if you use something that implements the code flow property, every time a new collector is set, you are actually duplicating your stream. So that's not the best approach for this case. Also, it also emits repeated values. If the server sends something and then sends the same thing, we will be handling this information throughout all the layers and processing this data and trying to update the interface, so that's not the best option. So we could go a little bit deeper and use an implementation of Flow, which is the shared flow. It has the good points of the previous guy, and it introduces new points that are good for us as well, which is the hot flow property. It's kind of different because now it is a downstream. It is a guy that is there, and you can just assign new collectors, and it will not create new instances for your stream. What's great. Also, it has a thread-safe way to like emit events. Like, let's just think of live data, which is something that we are used to. You have an instance of live data. You can just post value to this live data in a synchronous way, and you can do the same with the shared flow. You just have an instance of mutable shared flow. You can just set set events to that. But it also emits repeated values. So we can, again, go a little bit deeper and use an implementation of shared flow, which is the state flow. Everything that you emit into a state flow is a new state. It's a, let's say, state machine. Now, as it's like seeing it as states, if you try to send the same state again, it does not make sense. You are already in this state. So it will not send like the same value multiple times. Nice. Summing up, we have state flow, which can emit multiple values, exceptions handled, multiple collectors to the same downstream, just emit non-repeated values, has a thread-safe way to emit values, and is not an Android library. What's great? So we can say, now, we cannot say yet. We will get there. But that's how we implement that. Do you remember that I said that like live data that has the mutable live data, you can like send events in a non thread-safe way? So here we have the mutable state flow, which we create here. I don't know if you can see the, yeah, you can see it. Nice. All right, you can have the mutable state flow. It's a sealed class that are created here, the event state. And I have different states, like for the different like conditions that we will have throughout our system. The first one is to create the state, all right, the empty state. Then you have the on-open, which means that the connection was open to the SSE server. And the on-event is the important one, because this guy is the one that will be sent when we actually get some information from the server. And in the collection side, we can like collect it inside the view model scope. We can catch the problems. We could collect it inside our composable directly as a state, but here I'm trying to like catch it in a different way. And I'm creating a mutable state here in my view model, which is being consumed by my composable. So I'm just putting the value inside my state. All right, so state flow looks like a great option for a downstream in which we need to consume everything and have a real-time state updated. All right. Now that we have the three parts, which are the client-server communication set as SSE, the architecture set as a clean architecture, and the data stream as a state flow, we can have a clean view of the system in a sequence diagram of how it would work. First, the layers, the view model and the view as the UI layer. In the domain layer, we have the interface of the repository and the use case, and the data layer with the client, the data source, and the implementation of the repository. And here's how the system would work. The user opens the page, it will observe the state, which is in the view model, and it will request throughout all our layers the event flow. When it gets to the client, the SSE client, it will create the flow instance that will be consumed and open the connection to the server, and return the flow instance, which will be collected by the view model. And that's where we start dancing. Because from now on, for each event that we get from the server, it will go throughout all the system being processed and all the business that we need until it's collected by the view model and posted to be updated in your composable. And like every time you get a new event, it will work again until the user leaves the page and the connection is closed. That or sequence diagram, and like at the beginning of the presentation, I run the sample project that I built with a client that's like consuming as a test server, a test SSE server. Here you can see that first the empty event, the empty state, just to start our state flow. Then the request was created, the connection was open, and for each one of these rows, you have a counter of states we had so far, and the content that was sent by the server. Here is just a random word that the server sends. So we have a lot, and it's still being sent down there and down there. All right. That's it. Thank you very much for your attention. Like here you have a post that I did yesterday in the Pro Android Dev community. It's basically what I'm saying here. There are some references that I used. And to the right, you have the sample project that was created, basically the one that I showed there. And that's pretty much it. Thank you, guys. And if you have questions, let me know.